Hello, welcome to Maths with EJD. In the previous video on two-way ANOVA, we spent almost 2 hours trying to do the whole job manually. But thankfully, computing has made life pretty easy. All that thing I did, I'm going to do the same here using, just using a Python code in just how many lines of code? Just 75 lines of code, right? Yeah, so I mean, computing has made life pretty easy. All right. So instead of going through all that stress, right, you can easily just come and, write Python code like what you have here. From lines 1 to 4, right? It shows the libraries you have to import. Like you need NumPy for numerical Python, you need pandas for data analysis, you need stats model, of course, for this statistical analysis. Then we also need stats model for ordinary list square. So it is from stats model, the formula.api that you have OLS. Okay. So we need list square, we need the stat model itself, and then we need NumPy and pandas. So those are the four libraries we need. Then in line 6, we have test scores for each group. So the same test scores we had in the previous video, that's exactly what we have here. So method one, lecture, that's what I called 1-1, right? Teaching method one, and the lecture class type, and then teaching method one with lab class type, teaching method two with lecture class type, teaching method two with lab class type. So those are the four combinations we have from all that with all the 20 scores. So five for each of the combinations. Then in 14 and 15, so you see method is method one. We have 10, we have 10 scores, and method two also 10 scores. Then for class type, so for lecture, the first lecture, it's 555, right? So we have lecture five, lab five, lecture five, lab five, going by, distribution along the two methods. Okay. That's all you have going on in 14 and 15. Definitely from 7 to 12 or maybe 13, right? We have a Python dictionary there uh, containing the codes, which we now turn into a pandas data frame in line 19. So there we are creating a data frame, more like what you have in Microsoft Excel, rows and columns. So that to show you 1 1 1 2 2 1 2 2, and they are great. In fact, I can even try to visualize that. Let me just say print. I can say print df. This will be first thing to show. But I'm going to put a blank print here to create space for readability when we finally run this. Then in line 25 now, we have the comment about performing two-way ANOVA. So in line 25, 26, that's where the actual thing is happening. So you have the model. So here you need the ordinary list square. Then you have the scores for method, class type, method, class type, like that. So that's how that goes. And then you fit that. And then you also generate the ANOVA table, and that is coming from the library statsmodel.api. So all that. And then of course in line 30 now we print the ANOVA table. This is the ANOVA table. So this is line 30 is helping us to see that. Then from lines 33 to 37 now, we are extracting necessary values for interpretation. Like you want to see the sum of squares for factor A, you want to see sum of squares for factor B, which is then, it brings all that out with the method with the class type. Then sum of squares for the interaction, sum of squares for error, and then it's SST, that's sum of squares total. You see that there. And you need all this together with the degree of freedom, A separately, B separately, A, B together, and the error, we need that four. It is those four now that you now need to calculate your mean squares. If you remember how the process went when we're doing it manually. So lines 45 to 48 actually show you how to get the mean squares by dividing sum of squares with their corresponding degrees of freedom So MSA, for instance, is SSA over DFA and so on and so forth. Then, of course, we've come for the F statistics where you divide each MSA by the mean squared for error. So you divide MSA by MSC, MSB by MSC, MSAB by MSC. I mean, if you're doing it manually, before we got here, it was like 1.5 hours passed into the whole process. But I mean, we're already here in line 53 talking about Python code. If even if I was going to write the code from the scratch, it will still be faster than computing. I mean, doing it manually rather. So in lines 56 to 58 now, we are visualizing the F statistics that we got previously. I think I got 24 point something, somewhere 13.7 somewhere and all that. So um all that. Then in line 61, we have the critical value for decision. And then in 62, we are bringing in SciPy for statistics so we can get our F distribution because we need to get critical value, you need the F distribution table. So in line 65, 66, now we have critical value for F distribution. So with all the 1 minus alpha, DFA, degree of freedom for A, degree of freedom for E, correspondingly, and then you print the critical values for all that. Then in line 69 to 72, we can make the final decision based on whether what the condition rather, method one, FA greater than F critical. If all the test statistics are greater than the critical, then we have to reject. So for key value, if value print the null hypothesis for key is rejected for significant effect, else you print the null hypothesis is not rejected. So that means no significant effect based on the condition. So let's go and see what happens. So I'm trying to run that now, okay? Now you see this is, as we have put this into a table format. So we have the scores, we have the method and class type corresponding to that. And then here now, so the F statistic here is 2.2326. Are we sure of that? Let me see. F statistics for interaction, FAB, MSAB over MSE. Okay. This is 145.8, 72.2, sum of squares for type, then the class type. Okay, probably there's I hope not though. Maybe there's a little bit of inconsistency in what I did previously. So you want to check that again. I'm sure, definitely not going back to that. You can be sure of that. I mean, okay, this is sum of squares. Yeah, these are the F statistics. So for these two, they are definitely bigger. So I'm very sure something must have been amiss because the F statistics I got, it was a lot of calculation, so maybe something went wrong there. So you can check that out. But I mean, that's the process. So just be sure the calculation is correct. So, but this is, I mean, if I will choose one, I would definitely go for this ahead of that because this is computing and it's prone to, I mean, it's not like there can be error, right? But it's less prone to error compared to when you compute by hand. So I might have mixed up some numbers over there. But I mean, the process is correct. Just be sure the numbers are correct. So this is how it's been. I mean, in less than 10 minutes, we are done with the Python code. Even if I have to write the code from the scratch, maximum 20, 30 minutes will be done with this. So for better accuracy and for faster work, you can embrace using Python for things like ANOVA because it's really computationally intensive. So I've decided to do Python code for maybe things like repeated measures ANOVA and the multiple ANOVA. So I won't do manual computing for them. I'll just display the Python code and show you how that is done. So that brings me to the end of this video on Python code for two-way ANOVA. So when you're interacting with the previous video, do that carefully and be sure wherever I might have missed something, you don't make the same mistake. So till I come your way again, have a great time. Thanks for always joining. Be sure to sign up Subscribe to this channel. After subscribing, be sure to hit the notification bell so that you can always get alerted each time a new video is released. And don't forget to comment. Tell me if you need me to teach a topic or to um, solve a problem. I should be able to find time along the line to do all that. And of course, don't forget to like, also share with other people so they can be part of all this great learning. Till I come your way again, have a great time. Bye.